This is Matthew Small speaking. I head up solutions architecture for Bitnami, working with both our enterprise customers as well as our cloud platforms. We've got a great agenda for you today, taking you through how you can leverage as well as package your applications with Azure Database Services, leveraging the best of breed open source database solutions that Azure has to offer. To introduce Bitnami and get us started, Bitnami has been leading open source software packaging for many, many years. We have over 10 years of experience in packaging open source applications from every different format, from your desktop up through all of the various cloud providers and other distribution types like containers. We have over 150 applications, dev stacks, and other components that are available for you to use for free today from all of the cloud marketplaces, including the Azure Marketplace. We'll keep this right on moving here. Introduce Andrea here to start talking a bit more about Azure databases and introduce their offering.
Hi everyone, my name is Andrea Lamb and I'm a program manager on the Azure OSS databases team. So just a little bit of background, the Azure databases for MySQL, PostgreSQL, and MariaDB are all available in Microsoft Azure today. The MySQL and Postgres offerings went GA back in March of 2018, and we recently brought up the MariaDB service as GA in December of 2018. So we're very excited about some of our OSS offerings and excited to be here to talk to you guys today as well.
Thank you, Andrea. Before we jump in to showcase some of the products and capabilities offered, wanted to spend a quick moment on what packaging means. So packaging is the concept of combining all of the pieces required, all of the artifacts, including images and deployment templates in order to get those images and any associated PaaS services deployed, packaging those together into one versionable and maintainable artifact that you can use over time. And so Bitnami focuses on this effort by providing pre-packaged components as well as tools for you to package your own applications according to your organizational best practices. We help organizations optimize their application release pipelines in this way, and we focus on helping you optimize for security and speed. In our portfolio, we'll talk today a bit about the application catalog, including featuring 2 new solutions using Azure Database. We'll showcase Stacksmith and packaging your own custom application with an Azure Database. And we'll also talk a bit about our open source offerings in Kubernetes, showcasing KubeApps in the context of today's demonstration for provisioning of containers on AKS as well as an Azure managed database. Before we jumped into that, I did want to announce new public catalog applications are now available in the Azure Marketplace. Just head over to the Azure Marketplace portal and take a look for WordPress or Drupal, now featuring and pre-integrated with Azure Database for MariaDB. With that, I'll send it back over to Andrea for some summary of what Azure DB can do for you.
Thanks, Matt. Are you guys able to see my screen at this point?
Yes.
Perfect. So I just wanted to give kind of an overview about the services that we have to offer in Azure, particularly around the MySQL, Postgres, and MariaDB offerings. So one of the strategic directions that we went in was to use the MySQL, Postgres, and MariaDB managed community bits. This means that all of the bits that we run for the engines are all the community versions. And this was a decision that we made to ensure that developers are able to use the languages, tools, and frameworks of their choice. We wanted to ensure that developers didn't have to change the way that they use these specific engines. And we wanted to make sure everybody was able to kind of pick up where they left off, whether it's from a VM or on-premises and into our service in the cloud. Additionally, as part of the service, we do offer elastic scaling. This means that you're able to scale your resources in your servers as required to meet your workload's needs. And all of that can be managed via APIs or even the portal experience that I'll show later on in the demo. As part of our service, we also offer built-in high availability, and I'll talk about that in a little bit more in one of the following slides. Additionally, Azure is one of the most secure and compliant clouds. As part of that, we ensure that certifications such as HIPAA, SOC, ISO, anything that you need in a regulated industry are all available in the services that we have to offer. And today we're in 38 regions in Azure, so that means we want to make sure that developers all around the world are able to deploy their databases in whatever regions that they need to reach their end users, and we want to make sure that we continually expand into all new regions as Azure brings them up. Lastly, as part of as an Azure service, we want to ensure that we're integrated with all the other Azure services available, such as Power BI, app services, and this ensures that as a developer, when you're developing and you want to deploy resources, we do all that in as few clicks as possible. So as part of that, let's say you want to spin up a web app, we also allow you to spin up a MySQL or Postgres database alongside to ensure that everything is kind of managed and consolidated together. So as part of a managed service, what does that mean? So what we offer are many automatic parts. So that includes updates. So anytime a new security patch comes out for any of the engines, we try to get on that as quickly as possible and update all the bits that run in our service. And as part of that, you also get the new feature updates. So anytime we have any new features coming up in our service, all customers receive that once they hit public preview, and especially in GA availability. So this ensures that you keep up to date with all the features available across all the services. Additionally, we do offer automatic backups. So all of your servers are backed up on a schedule, and we have more information about that in our documentation. We also offer built-in encryption for your data and for your backups. All of this includes the SSL that's enabled by default, as well as storing the data with a AES-256-bit encryption in the back end. So we mentioned high availability and scaling in seconds earlier on. So what this means is in the Azure Portal or via some CLI commands or APIs, you're able to scale your compute and your storage resources as you need. This allows you to meet your customers' demands. Let's say during peak business hours, you want to scale your server up. And then once peak business hours are over, you can scale it back down for cost savings. All this can be done for your server. We also include the 99.99% uptime SLA. And what this means is for every individual server in our service, each one of these servers has this SLA. And this is a money-back guarantee of sorts that we give you to say, hey, we guarantee that your server will be available for 99.99% of the time that it's up. And if it isn't, then you can contact us and we can talk about how to potentially refund you if necessary. And this is, like I mentioned, for every single one of your servers. So this means that you don't have to create a second server that runs in the background, that runs as a standby or as a replica that needs to be up in order to guarantee this SLA. Like I mentioned, it's all for each individual server. As well as, we do offer disaster recovery scenarios. So if your server goes down in one particular region, you can quickly create a second server in another region to get your business back up and running. And if you're interested in moving to our service, we do offer a bunch of different data migration resources. So please check out some of the links on the screen. This covers migrations from on-premises, virtual machines, and other clouds into our cloud service. And with that, I'm going to hand that back over to Matt.
Great, thank you, Andrea. So we'll do a quick demonstration here, and I'll show you where to go and find the new resources for Azure. If you're going to the Azure Marketplace, just take a look for the WordPress for Azure database for MariaDB. That will allow you to launch a full WordPress stack using a managed database backend, including all of those capabilities that Andrea just described. You can also find a similar product here for Drupal using Azure Database for MariaDB. And in both cases, these are entirely free for you to use. You'll simply hit the Get It Now button. You will, of course, pay for the Azure resources that you consume in your Azure subscription. There are many other free applications available and more coming to leverage the Azure database services. I also want to take a moment and highlight the Bitnami Enterprise Catalog. This is distinct from our application catalog that you can find in the Azure Marketplace, as well as the other cloud marketplaces. And the Enterprise Catalog allows you to get Bitnami certified open source applications delivered directly to your private repository. This allows you to get these apps pre-certified, understanding that they have no security vulnerabilities, that they've been vetted and tested before they land in your organization. They're well architected and just work using the native cloud services, as well as maintained over time, including the open source software updates. The system package and any CVEs that affect those packages are addressed in a continuous manner, and they continuously land in your environment, directly to your organization. We can offer point solutions with relevant or sector or industry specific solutions such as big data or learning management, depending on what your requirements are. The Bitnami Enterprise Catalog, as well as your own custom apps, third-party software, and configurations can also be packaged with Stacksmith. Stacksmith is a tool to apply your centralized policies and control to artifacts at build time. We can pre-build some of those artifacts, taking off that onus of you to go out to these various open source projects and compile these from source or build from their release binaries. We already do that. We already test those. So you can leave that to us. You can, of course, also take your own apps. Moving them through Stacksmith allows you to apply your organizational policies to them, such as security hardening scripts for the images, or the configuration of centralized logging and monitoring tooling. It also allows you to tweak our standard configurations, such as the way we set up Azure Database by default in the ARM template for deployment. These applications that you package with Stacksmith can be sent through to your service catalog, giving you deploy time policy control. That can include the Azure Managed Application Catalog, as well as Cube Apps, which we will showcase today. With your custom apps, you can build any of your Linux apps with Stacksmith, packaging those with Azure Database Services and other cloud-native services, allowing you to define pipelines for how those applications need to look and be refactored for deployment to the cloud. This allows you to modernize existing applications as well as package net new application development, including 12-factor apps. Key use cases that Stacksmith addresses are continuous image and application security. That is ensuring that the things that you have that are immutable are continuously maintained. As updates to your configuration policies, as updates to system packages, and other components upstream are made available, Stacksmith pulls those through, regenerating the artifacts on demand, ensuring that you have the latest and greatest updated assets delivered to your pipeline, through your pipelines. You can use Stacksmith to re-platform existing applications, perhaps from one data center to the cloud or from one cloud to containers. Stacksmith allows you to regenerate using the same source inputs, application code and configuration logic and an orchestration template, and allows you to take those and platform them natively using the native image types and PaaS services on your target cloud. This replatforming can help you take advantage of native cloud services and the differentiation that Azure can provide if you are migrating your applications from the data center to Azure. Lets you leverage those first-party services that compel you to make that transition in the first place, going beyond a lift and shift. Once you've defined some standard policies for how you build and maintain your artifacts, Stacksmith can ensure that they're enforced. We look at this from enforcing DevSecOps best practice standpoint. Developers care about opinions such as how the application is configured and what dependencies that it has. Security cares about things like OS hardening process, as well as configuration of centralized tooling like an IDS tool on every artifact, VM image or container that may be passed through that pipeline. And operations cares about what this application looks like and what SLA it needs to be architected to achieve once deployed to the cloud. Stacksmith can ensure that those opinions are programmatically enforced and that those individuals on those various teams, developers, security team members, and operations team members, all have the ability to independently maintain their opinions about this process, and Stacksmith will pull them through as those change over time, ensuring that everybody has the ability to contribute their configurations and their policies to the build time process. And finally, as we'll showcase today, Stacksmith can ensure that your enterprise service catalog is maintained with the most up-to-date artifacts. Just like we maintain the most up-to-date artifacts in the Azure Marketplace, you may have your own private service catalog, such as ServiceNow, an Azure Managed Application Portal, an AWS Service Catalog, or what we'll show today in Kubernetes with KubeApps. You can use those to apply deployment time policies to your launches. So Stacksmith will focus on the building and the maintenance time policies, and a service catalog can help enforce deployment time policies. One of the best things that you can do in a mature IT organization that's offering cloud services is offer a service catalog. But one of the catch-22s there is that if you let those things in that catalog get stale and outdated, that opens you up to security vulnerabilities and other negative impacts. As mentioned, we will highlight KubeApps today for the discovery and self-service of applications in Kubernetes. In our demonstration today, we'll actually be using KubeApps deployed into an AKS cluster to self-discover the application we packaged with Stacksmith, to deploy that and show you how you can self-manage that application over time. KubeApps provides a nice and accessible abstraction and GUI interface into the process of launching applications into Kubernetes clusters, giving your users and consumers in your organization a simplified experience in accessing those. Please note that this is free and open source. We would love for you to join us in the KubeApps channel in Kubernetes. If you adopt this and take a look, we'd certainly love your feedback. One final note is we do offer the Bitnami Kubernetes production runtime as well. After you've launched your AKS cluster or any Kubernetes cluster, fresh cluster, you need to configure things like monitoring, logging, and ingress to properly configure that according to, in order to receive applications. Bitnami, of course, can provide those applications as Helm charts, but BKPR allows you to quickly configure popular open source projects, and those are pre-integrated. BKPR does support site-specific overrides if you have a preferred alternative for monitoring, logging, or ingress tooling. So this meets you where you are with the tools and preferences that you have, but makes the bulk of the heavy lifting here to make your Kubernetes clusters application ready very simple to execute. So without further ado, let's pop over into the demo. Today we'll be demonstrating Stacksmith KubeApps, AKS, and an Azure database on the back end. In Stacksmith, we will package a new application, a WordPress, for Azure Infrastructure as a Service using an Azure database, as well as Kubernetes, but also leveraging an Azure database. We will deploy that packaged application using KubeApps to AKS, and that will leverage Open Service Broker for Azure, which is an open source project from Microsoft that is pre-integrated with KubeApps and allows us to operate native Azure cloud services using a Helm template. Helm is the de facto standard package manager and template language for Kubernetes. And so this allows you to do hybrid deployments on containers, as well as using best of breed backend services on Azure or other clouds of your choice. So let's pop over and we'll start with Stacksmith. Here I'm operating within a Stacksmith project. This is my view having just logged in. A Stacksmith project is tied to, in this case, an Azure subscription in which I am packaging my applications. Stacksmith ensures that this entire packaging process takes place within your cloud account. And so the things that you're uploading to the process, such as code files or configuration logic, never leave your virtual data center walls. That Stacksmith project you can use independently. Of course, you can also have an organization-wide policies with different packaging environments, controlling where and in what tenancies you want to package your applications. We're going to go through the GUI experience today of packaging an app. However, I want to point out that there is an API and a command line interface into the things that I'm going to show you today. This allows you to hook Stacksmith up to your CI pipelines upstream, for example, to feed Stacksmith with applications. This also allows you to hook Stacksmith up to your Git repositories to follow a GitOps workflow. The UI, however, gives an accessible way for applications that may not have a mature software development lifecycle or process. It helps to take steps toward modernizing those applications for a better fit of cloud deployment. Let's say they're coming out of a data center and you don't, or there are legacy applications that need to be replatformed. So Stacksmith is an accessible best first step for those applications as well. So in packaging a new application, I'm going to put my application owner hat on now, and I'm going to give my app a name. We'll call this WordPress with Azure DB for webinar. And we will give, I'm also going to type kubeapps here. That is my, well, I ran out of space. We'll call it web. I'm also going to type kubeapps here in this particular project in Stacksmith. This is just a bit of glue that I've created so I can send these to different service catalogs such as ServiceNow or kubeapps or the Azure Managed App Portal selectively. Of course, you can configure Stacksmith in other ways. As the application owner, I also care about the version of my application. This could be tracking the version of WordPress that I'm about to install. It could be your custom version of your software, or tracking the version of a commercial off-the-shelf or open source piece of software that you're packaging. I believe we're on WordPress version 5.02 here, which I'm going to add here. I will then select a stack template. And a stack template provides two things to the process. It applies the orchestration template or the deployment template, in this case an ARM template, as well as a Helm chart with the best practices for deploying this application. And that is contributed by your operations team. They will go into that stack template configuration and they will add their ARM templates and Helm charts or other formats in order to package applications with those best practices. One other note is that they can also enforce any image customization that must be applied to anything passing through this pipeline. This is typically used to enforce security hardening policies or other key elements that need to be configured on that image. Those repository URLs can be added here, and hooking Stacksmith up to your Git repository ensures that as those opinions and configuration policies change, new artifacts are generated through Stacksmith to conform to those new changes. I'm going to select this generic application with a managed database, and it will use the Azure database for MySQL in this example. I can select an operating system. I can select my target or targets, plural. Stacksmith allows you to have one set of inputs in a single process to package for multiple output formats. I can add application files, such as in this case, I might want to add some WordPress plugins, which I can simply add as application files here. I can also elect not to provide Stacksmith with an application file. And in fact, in this case, I'm not going to do that in the interest of time and my upload speed. And instead, I'm going to just point Stacksmith to a Git repository where I'm installing WordPress from the command line. This is the application reference architecture that we're actually going to package and deploy. You can get this, this is freely available for you to test yourself. I would certainly encourage you to do that. And all of the instructions for what I'm going to do are here, as well as additional instructions showing you how to automate this with our command line interface. Now, the scripts that I need here are stored in this user scripts folder. They include a build script for any additional application dependencies. They include a boot script to get WordPress started and running, and a run script to start the application. To give you a sense, this boot script is available in source form here. It's quite simple. Really all we're doing here is using a shell script to set our Azure database options, wait for it to become available, and configure WordPress. Again, we're using the WordPress command line interface to install WordPress in this example. Of course, you could also supply the WordPress binaries or compiled binaries, I should say, into the process. The nice thing about this is that as this boot script changes, I can track those changes directly back in Stacksmith and ensure my artifacts are properly regenerated. Here I'm going to take this URL. I'm going to add the repository URL here. We're referencing the master branch, and I'm going to hit create. That's going to add these two releases into, we'll put these into the oven here. We're going to be building a Helm chart driven WordPress deployment using a Docker container and an Azure managed database for MySQL. And we're also going to be generating an ARM template and an Azure managed disk image with WordPress with an Azure database for MySQL on the back end. This process does get logged. Those logs are persisted. So over time, you can ensure that you have a clear understanding of how all of these artifacts were built, as well as other details about those artifacts. We'll let those builds kick off here, and I'll show you some of the day 2 operations that you can perform with Stacksmith as well. Here you see other applications that were previously packaged, including another version of this application that I packaged earlier this month, about 20 days ago. What I wanted to show you here was that I'm using that same repository URL as an input, same master branch. Here are my outputs to the process. My container with WordPress is stored in Azure Container Registry. Of course, you can point Stacksmith to the location that you would like your artifacts to be output to. We've also generated a Helm chart, which is stored here just in Azure Blob Storage. Again, this is all within my Azure subscription, meaning all of these artifacts are stored securely in your locations. I also have the ARM template release here, as well as a managed disk image ID, again, stored in my Azure subscription. However, what you'll notice is that there are updates available for both of these releases. These updates include system package updates. Here you can see the entire manifest of all of the system packages that went into the images generated as part of this process, and a quick and easy way to understand which of those packages have since been updated. So some pretty critical updates here for Perl and systemd and TZ data that I might want to add in to a release. I've turned off automated updates here to show you how this thing can get out of date, but we will repackage it in just a moment. Before I do that, I also want to show you how we're tracking the Git repository that's used to configure that application. So here we actually see direct references from the things that were updated within that repository using a GitOps workflow. That feedback is shown back here, and I know that when I repackage my application, I'm going to get these new updates that have since been merged into my scripts from Git. I'm going to go ahead and click this repackage button. That's going to take the same inputs to the process. We can kick off one for each, and it's going to pull in these new system package updates as well as the new updates from my Git repository in order to reconfigure my application. Again, this entire process can be triggered continuously as updates are available, ensuring that the latest artifacts are generated. Or you can provide a manual process like I've shown you here today to have some eyes on this before you actually repackage and regenerate those artifacts. We'll pop back out to our applications view here as we have things that are now in the process. So what I'm able to do here is take a look. Looks like we're still building that image here as things continue to go. We'll take a look, we'll check back in here in just a moment and get our final release. As you can see, I can package multiple application types, including Java apps, .NET Core applications. Stacksmith does support any Linux application. As mentioned, you can also hook this into a CI pipeline, where you may have many releases with a lot of history over time of those releases. As new versions of your app are checked in, Stacksmith can automatically pick those up from your upstream CI tool of choice. That CI tool can increment the version and ensure that things are kept maintained over time. Again, since Stacksmith practices immutable configurations here with images and deployment templates, I can always roll back to a previous version of my application to grab my deployment template as well as the very specific package point-in-time images for that particular release of my app. This allows you to modernize some of your deployment practices, including looking at opportunities for canary deployments or blue-green deployment. Of course, you can also use these deployment templates to do an in-place upgrade on your application. It does appear that our Kubernetes flavor is now completely packaged. So here's the log of the entire process. As you can see, that log is now persisted. It's also exportable should I need to send that to another logging tool of choice. I do want to point out that we actually use the best fit capabilities within the cloud providers in order to build these containers. Here you can actually see we're firing up Azure Docker Builder, which is the ACR build service, in order to build these containers. So I can certainly download this Helm chart, pop over to the terminal and show you how to install it from the terminal. But instead, I'm just going to actually pop over here into my kubeapps dashboard. As mentioned, kubeapps is an in-cluster service catalog for Kubernetes. It can pull in applications from any public or private repository. Here you see quite a few that are available in some of those public repositories, and this will run in your cluster. So here you can see we're actually running that in our AKS cluster here. Of course, Stacksmith generated applications can also be pushed over here. And so we have our WordPress apps that are created that I can simply pull in and deploy. Deploying this application using Helm allows me an abstraction in order to get this app deployed without a deep knowledge of the Kubernetes command line. New, we'll just call this new WordPress. And I can get direct access into some of my deployment time parameters. The same would be true if I'm deploying an ARM template through the Azure Portal. I have the ability to set deployment time parameters at that stage as well. But for example, if I wanted to change some of my default settings here, you know, an unsecure password, of course, I could also incorporate some secrets management into this as a best practice. But you get the idea of how you can quickly set up those deployment time parameters, inclusive of the parameters for the external database. So here we're actually configuring that Azure database and setting that up using MySQL. Submitting that puts us into a deployment state. That will deploy my application. It automatically sucks out some of the important details for this application as defined in that Helm chart for deployment. And so I can access that application. It shows me what resources are currently being configured. So those resources are currently pending. I have one container that's going to, one deployment. In that deployment, I have a container that's going to deploy my WordPress application. It is a load balancer type in Kubernetes, meaning it's going to get an external IP for me in order to access that application. Boom, there it is. It's also provisioning and configuring the secrets required, setting up a persistent volume claim in my AKS cluster. And then here's the important part here with Open Service Broker. Open Service Broker is allowing us to do a service binding and provision that Azure database backend. Open Service Broker, as I mentioned, is pre-integrated with KubeApps, so you can actually set up those and manage those service instances directly from the KubeApps UI as well, giving you the ability to directly control those native cloud services using Open Service Broker. We have our new WordPress here. Looks like it's still buttoning up in its deployment here. We'll give it a quick test to see if we can find a route in. Kubernetes is eventually consistent, so this may take a few extra minutes as it's configuring its route into my AKS cluster, but we'll let that one crank in the background. And while we're doing that, we can actually pop over and we can take a look at some of the resources and review some of those resources to get you to those next steps. And we'll come back and we'll finish with our application. At this point, we'll certainly take any questions that you may have. Any of those that you can use the Q&A panel to submit those. I also want to give Andrea a moment here to highlight some of the Azure resources that are available.
Yeah, I just kind of wanted to highlight how to get to the Azure database services using the Azure Portal and just a quick overview.
Absolutely, please and thank you.
So sharing my screen again. All right, so this is the Azure Portal. Essentially, it's a way for you to create and manage all of your Azure resources. So the quickest way to create an Azure database for MySQL, Postgres, and MariaDB is to actually go ahead and click the Create a Resource button up here in the top left-hand corner. From there, it takes you to this new panel. You can quickly scroll to the Databases category. And from there, you can see that we offer SQL Managed Instance, but for our particular case, we're going to focus on these three, the MariaDB, MySQL, and Postgres. So let's click on MariaDB. From there, it takes you to a new server blade. This is where you go and you specify the name of the server. So I'll just create this, for example, MariaDB. If you have an existing subscription, you can select from your choices of subscriptions as well. And then from there, you can create a resource group. A resource group is essentially a container that's used to manage all of your resources. So I'm just going to create a new one. Oh, no resources. So create new, hit OK. And then we also offer the ability to create a server from a previous backup. So if you wanted to do that, you could actually click backup. We'll stick with blank for now. And then from there, you go and you provide the server and then login name and password. and select where the server is going to be located in our 38 regions, select the version of the server, and then configure the server with the pricing tier, as well as the compute resources and the storage. You can do all this using the sliders, as well as the APIs that we provide in our command line experiences. Switching over to the slides again, let me go back to the resources. Some of the resources I did want to highlight are where you can get more information about all the services. So starting with aka.ms/PostgreSQL, MySQL, MariaDB. This links you to pricing pages as well as documentation. And you can read up more about the service and get quickly started on creating your first server today. And if you have questions, you can definitely reach out to us either on MSDN or Stack Overflow. And we also have a Twitter handle for each of the 3 services that you can tweet at us with. And lastly, you can also file feedback at our user voice forums, and those are all linked there as well. And Matt, I'll let you take over again.
Thank you very much, Andrea. Also want to talk about a few next steps here with Bitnami and Azure. If you have some use cases or integrations you'd like to discuss, you can reach us at Bitnami at enterprise@bitnami.com. If you're ready to evaluate Stacksmith, we do have a trial available of our Team Edition, allowing you to get access to the features and capabilities that you saw today. If you're an open source developer, check out Stacksmith Public. This is a free version of Stacksmith that you can connect to your open source projects in your various Git repositories and package those applications for free.